Hey everyone, hope you had a good spring break. Back here with our first lesson for LING120 online, fully online. So I've got a PowerPoint for you here. I might switch between this and Chrome a few times, but we can go ahead and get started. So this is for March 23rd. I'm going to try to make this as close to the normal in-class lectures that we would have. So we'll do what we can. So Chapter 5 is all about text classification, and there's a lot of machine learning that goes along with this. And machine learning has a lot of different applications and a lot of different fields, very complex topic that you can really get into the math and the stats behind it. I don't think we need to, but rather we're just going to get an overview of what machine learning is and where it can be used. So one fairly straightforward application of machine learning is text classification. So here I've got this text from, I guess, Shauna to Eugenio, and we need to decide whether or not this email between these two is spam. So this is one example we're going to come back to rather frequently with machine learning and text classification. Keeping in mind that text classification is just kind of one application of machine learning. This is an example we'll come back to kind of throughout. So if you were to look at this example and decide whether or not it's spam or ham, right, spam is where the email is not something you want to read, it's fake, whereas ham is the opposite, something that's actually a real email. This is pretty easy to decide that it's a real email, something you need to pay attention to, right? Whereas this one from the Powerball Lotto is very much more obviously a spam email. And so you look at these two, and it's fairly obvious which one is spam, which one is ham. However, we need to teach the computer how to be able to do this automatically. And we'll talk about why we might do this automatically later on with some more applications. But kind of the thing to keep in mind for the moment is that it's very easy for the human to do, but we need to teach the computer how. So how can the computer look at this language and decide that it's spam or ham? So first off, a couple more examples. What about like job ads? If you get a job ad into your email, is that spam or is that ham? And with it comes a whole bunch of times. Does that change your opinion of whether it's spam or ham? Is it good or bad? What about like group emails? Do you want those in your inbox if you're going to use machine learning to automatically classify emails in your inbox as spam or ham? Group emails, do you want those? Or do you want those to go to spam? Text messages, do you want maybe your cellular service provider to automatically take out those types of messages? Are you satisfied with your email filter? Could if you use Gmail or whatever you happen to use, do you think they could do a good enough job at it? Do you get a lot of spam into your inbox, and do you get a lot of your real emails into your spam? And so importantly, the question we need to ask is what's going on under the hood, kind of on the back side of all of this. So that's what we're going to talk about now. So when we talk about classification, in general, this means grouping these entities, maybe these texts, these documents, into a predefined set of classes based on their properties. So, for example, in the spam ham example, we look at the language used therein in the email. That might be our text is an email, and decide whether or not it goes into spam or ham. Those are our classes. And so we want to classify these based on their features, whether they be linguistic features or non-linguistic features. Some non-linguistic features might include things like font color or capitalization or the use of large numbers, I don't know, things like this, versus things like more obviously linguistic, such as number of nouns, number of verbs, what have you. So here's more examples to wrap our minds around this. Classifying Amazon reviews as book review, movie review, electronic review, other type of review. They may get hundreds or thousands, I don't know how many of these per day. New on Amazon, they don't want to have to manually sort those, for example. Or movie reviews, positive or negative sentiment, to be able to group those. Detect if a word refers to a person or not, We've actually talked about this already previously in the class. This is called named entity recognition. So classifying whether a word is a person or not, NER, named entity recognition. Telling if a website's content is suitable for children. You could do this automatically with machine learning. Look at the content in the website and decide whether or not this should be hidden behind the the filter that parents put on there, or maybe classifying a text based on what language it's in. Some different examples. And we'll keep in mind that these texts that we're talking about, text classification, these can be documents, sentences, or even at the word level, depending on what your purpose is. So a little bit more about these classes, these predefined classes. We might ask a human annotator to categorize a small collection of these texts to figure out what the classes are. And a lot of times for many known classification tasks like movie sentiment reviews, spam ham filtering, these types of things, we have some predefined classes that we can use to develop these classification models. So talking about how difficult it is, let's say we wanted to classify English language learners as beginner, intermediate, and advanced, and we have 1,000 texts for each category that we had expert English teachers rate and classify into these 3 categories. How would we go about developing a classifier that can do this all automatically? Will we look at vocab? Will we use n-grams, right? Bigrams, trigrams, things like this? Should we look at just the errors in the texts? Should we look at the syntax, the morphology, the spelling? What can we look at? Or should we combine everything? And if so, how? And then how do we work with all those 3,000 documents and try to come up with patterns of their vocab use or their syntax use or error usage, whatever? How would we go through and find the patterns to make the computer be able to classify future texts automatically? So we use machine learning for this. And basically, if you show a computer several examples of something, usually several refers to several hundred or several thousand a lot of times, maybe more, it can learn the patterns in these examples, draw the patterns automatically through use of maybe statistical analyses, and then it'll identify identical occurrences or similar occurrences for new data. These patterns can be the use of certain words, certain phrases, certain syntactic structures, different things like that. And then we can use complex statistical modeling to kind of draw these patterns. Again, we won't go into detail with this. If you are a stats person or a math person and you want to kind of go forward with this for your final project, that's definitely a place for you to look into. But we won't go into it much in 120. So we'll have access to some set of examples, and we generally call this the training set. So these are the data points that we give to the computer, and we tell the computer, like in the spam ham filtering example, here is an email and we classify this as spam. Here's another email, we classify this one as ham. And you give it the answer for every single text, every single document. And our goal is to make the machine learn what we want it to learn from all those examples. And then to approximate what it's learned, we test how well it does on a test set. So again, another example, maybe you'll have 10,000 texts in total that you can work with for machine learning. You take the first 1,000 of those, or you take 1,000 of those randomly, and you put them through the machine learning as your training set, put them through the algorithm. Then you take the remaining 9,000, you use those as the test set, and you're going to see how well did the machine do at learning what you wanted it to learn. And you can use your precision, accuracy, precision, and recall scores to calculate how well it did on the test set. And then if you're satisfied, you can start using it for real-life applications. If you're not satisfied, you can find another algorithm, for example. So there are 2 major types of machine learning. There's supervised and unsupervised. In supervised learning, we know what the categories are. It's spam or it's ham. It's a positive movie review or a negative movie review. It's a sports article or a non-sports article. Things like this, where we can tell the computer, here are the categories we're looking for. In unsupervised learning, we want to have the computer automatically categorize all the texts into unknown or hidden categories. So an example of this is Twitter. We might look at all the tweets on Twitter for a given day or a given moment in time, and we want the computer to automatically classify them into the trending topics. So I think, what is it, the top 10 trending topics or something like that on Twitter. You can just tell the computer, hey, I don't know what the topics are going to be, but I want you to find the 10 most the 10 most common topics being talked about on Twitter right now. And so the computer finds 10 topics. And so these categories of what those topics are, right now, one of the topics might be coronavirus, but you don't have to tell the computer that the first topic might be coronavirus, and topic 2 might be something different. Rather, you just tell the computer, find 10 topics, or find X number of topics, depending on what your purpose is. And then it finds that. So how does this happen? So there are two main steps. First off, we have the feature engineering, and then second, we have the learning algorithm with the specified method of weighting our evidence. So let's talk about the first one, feature engineering. Let's go back to our spam and ham example. If we want to classify these emails, what features could be important? So maybe you want to pause the video and take a moment to think about this. So spam and ham emails, we might look for things like mentions of large sums of money, things like spelling errors, things like syntax errors, right? We can find syntax errors based on like POS tagging, these types of things. Yeah, and maybe you can find a list online of some vocabulary items that are more common in a spam email than a real email. Things like this. We can look at those types of features. If we want to classify learner texts into their levels, we might look at the frequency of vocabulary. We might look at syntactic complexity. There are ways to do this automatically, and plenty of other types of things. So there are two main ways we can do this automatically. We can use the kitchen sink strategy. This is the technical, very literally the technical term, the kitchen sink strategy, where we throw everything at it, perhaps even the kitchen sink. You give it all the features that you can find, all the different words, all the bigrams, all of the syntactic categories, just everything. You give everything to it and tell the computer, do what it can. And that's useful in some scenarios. In other scenarios, you want the handcrafted strategy where you know that some features won't be helpful, but other features will be. So you might choose some specific features by hand, like all the words that are in capital letters, or all words from this particular list that I expect to be relevant to making these classifications. So you could use a more handcrafted strategy. And so there are advantages and disadvantages of each of these methods. The kitchen sink strategy, you're not going to have a shortage of features to look at, but it also maybe it's computationally more taxing, and maybe there's some features that aren't going to be relevant, things like that. Handcrafted strategy, and also you don't have to spend the time in the kitchen sink strategy trying to think of what all these different features will be necessarily, whereas in the handcrafted strategy, you have to be very specific. And so that takes time on the human's part to come up with these specific features, but there'll be some advantages with that as well. It's very, very specific, which is good. So again, we can look at particular words, n-grams, POS patterns, part-of-speech patterns, or special linguistic structures like a number followed by preposition, right? Things like this. So moving on. Our learning algorithm. I said that there was the feature engineering and then secondly the learning algorithm to do your machine learning. So our goal in the learning algorithm is to take a feature representation of our training data, of all of our texts, come up with a function, a mathematical function where you can assign weights, right? Some things are heavier and some things are lighter, quote unquote, to individual features, and use that function to predict the category for any new text that it sees. Here's an example. It's not a very good example. I don't know that it's not a real life example. It's one I just made up, but I think it gets the point across. So let's say we have all these emails, and some of them are scams, and some of them are emails to a graduate student. And we've decided to use a handcrafted method of feature engineering, and we've decided on a few features that might be useful to us, like typo here. Large numbers, or specifically the number of large numbers in a text. I guess maybe not a typo. The number of words that are in all capital letters, the number of academic words. You could have a predefined list here. So these will be the features that we decided are important to us. And so we'll have a training set, which will be 1,000 texts. 500 of them are labeled scams, and 500 of them are labeled grad student emails. And a human went through and labeled all 1,000 of those for the training set, and also for the test set, obviously, because that's how you're going to test the computer. You don't give it those labels when it's going through and doing the test set, but you'll check it. So now we have our algorithm. So again, this is a made-up algorithm. I don't think it's valid at all, but it gets the point across. So our prediction score, our score for a given text, might be that it gives negative 0.3 times all of the capital letters, and then another negative 0.9 times all of the large numbers, right? And so here, these negative numbers, if I can find my mouse, the negatives here suggest to me that this might be a scam. So the lower the number, maybe it's a negative number or just a low number in general, might indicate scam. And so that's why my mouse just doesn't show up. That's why these are negative, because they are indicative of scams. And then maybe we can say that all capital letters are not as important or not as indicative of scam as large numbers. That's why the 0.9 is larger than 0.3. Large numbers could be a very clear, obvious sign that this is a scam. All capital letters might be more or less a certain sign, but they're both leaning towards scam. That's why they're both negative. Whereas academic words from our academic word list here in our features, this would be a positive, so indicative of a real email to a graduate student, and maybe we say it's 1.1, so it's very strongly, compared to these two, very strong indicator of a real email. So that's why we've got the positive and negative numbers. That's why some numbers in the formula in the function are larger than others. But we can use this made-up formula to predict whether a given text is a scam or a real email to a graduate student. And then later on, when we do the test set, we can we can find all the words that are in all caps, count those up, multiply that number times negative 0.3. Find all the large numbers, count them up, multiply it times negative 0.9. And then find all the academic words and multiply that number times 1.1, something like this. Get a number, and if that number is really low, like less than or equal to 1, then it's a scam. Otherwise, it's going to be a graduate student email. So that's how we could set up our learning algorithm, just as one example. Note that there are lots of algorithms available, and they're not necessarily this simple, and that new ones are being created all the time. It's an area of research, so note that this is a very simple example, but it gets the point across. And so our job will be to choose a couple of algorithms, run our models, right? Run our training set and our test set using the different algorithms that we choose, see which algorithm works the best, because some algorithms might return better results than others, because the computer will make mistakes, and you want to try to minimize the number of mistakes that it makes. So the pro for us as 120 people is we don't necessarily need to know how all of these algorithms are working. I'm not a statistician by any means. I just have some understanding of basic stats. A lot of these machine learning algorithms I don't understand fully, but it works, right? I can implement one of these machine learning algorithms, and it will do the job that I want it to do. The con is that we're working with a black box. We don't really know what's going on behind the scenes, and so that can be, some would consider that a weakness, but it depends on how into this you want to get. So as kind of a fun example, and also a bit of a required example, is I want you guys to go ahead and do the Zoink problem. It's on Canvas under resources. Actually, I'm not sure if I put it there yet, but it's here at this link. And so I'll walk you through this, and what I want you to do is work on this for 20 minutes. You can finish it if you want to. I don't think you need to finish it, spend an hour, hour and a half on it, whatever it might take you. I think you'll get the point of the activity after about 20 minutes or so. And then put what you found under as your comprehension questions for today, part of your comprehension questions for today. So let me go ahead and go to this link. I think I have it pulled up here in Chrome. Okay, and so this is a problem that I think kind of helps us as humans to get an idea of what the computer is, I guess, experiencing when we ask it to do machine learning. So you can go ahead and read through the intro to this activity. Basically, we have these words like good and great to describe different things. You'll go ahead and read through all of this. I don't need to read it to you. But then you'll have, so we have words like good but not great, furious but not angry, and we can classify which of these are acceptable, which ones are, right, because good is less intense than great, but furious is not the case, that furious is less intense than angry. So this is not an acceptable statement, right? And so what we want to do, what your task is to take these 17 made-up examples and classify them as to, where's it at? Yeah, you want to classify them as whether they're correct, wrong, or maybes. Right. So, and then at the end you'll be able to do you'll be able to finish this activity. So I want you to spend 20 minutes or so on this task. Try to do your best, figure out how to go about this task, how to decide which of these how this all works. And when you're done, go ahead and post your answers on Canvas. Good. And so once you're done with that, once you've done that for about 20 minutes or so, I think you'll have a better idea of kind of what the computer is experiencing. So pause the video now. I'm going to go through some answers. So pause the video now and work on that for 20 minutes. You don't need to finish. That's okay. So Zoink answers, I think it's called NACLO. Yes. It's like the American Association of like maybe computational linguistics or something. NACLO. Let's see. Where's it at? The answers were in here somewhere. Yes, I think this is the one. So I'll scroll down. The Zoink problem, I think, is in here. Yes. So I do encourage you to use your resources. The answers are right here online. So they have, this isn't the one. I will post the answers. I'll post the answer. Okay, I had them earlier. But for the meantime, I'll post the answers and you can go through that and read their explanation and kind of understand how this is related to machine learning. So with that, we'll get back on topic. So a recap so far. Our steps in doing text classification or machine learning is we need first a collection of example text with our known categories. So where the humans went through and put the labels on the data, right? This email spam, this email ham. That's our training data. Then we extract features that we want the machine to learn from these. That's our feature extraction phase. Then we give these to a learning algorithm where we do the training or the learning, machine learning phase. And then we test it on the test set, our test data. We see if the learned classifier is doing well on the test data. And then we can, the humans went through and added labels like spam and ham to each document in the test data. We calculate the precision, accuracy, and recall on how well to see how well the computer did with the test data. So for example, maybe most of the spam emails it identified, but some of them it missed. Maybe it incorrectly identified a few of the real emails as spam. And so we have to evaluate how well it did. If we're happy with how well it did, we can start using it in a real-world application. If we're not happy, then we might choose a different algorithm. We might alter the feature extraction, the feature the which features we choose, things like this. So to give you another example, kind of more or less real life. So we have these ham and spam text messages. This would be the training data. We'd actually have a lot more of these, but just for demonstration, we have these ham and spam text messages. What would we need to do next? We need to extract the features that we want to learn from. So we can extract all the features as words, for example. If a word occurs more frequently in spam than it does in ham, like the word urgent, for example, then perhaps it's indicative of spam. And so I've got a couple of different examples here. They kind of, I don't have one example that kind of goes through the rest of the slideshow. I need to switch between examples. So just kind of bear with me here. So if we've got ham and spam messages, and we're going to take each account of all the different words and see which one is more frequent. So switching to a different example, this is from a different email collection. We got words like cash appeared in many of the spam emails, also in a few of the ham emails, whereas the word Alice only showed up in one spam email, 50 of the ham emails. So we can write a program that counts all these word frequencies and try to figure out which emails are spam and which ones are ham based on which words show up. I think this is actually from the textbook. And so we'll put those through the learning algorithm in its training or learning phase. And we might see something like the word cash appeared 203 times in total in the training data, and 200 of these were spam. So what does that mean? Well, that means that if you see the word cache in your test data later on, it's almost certainly going to be spam, probably like 99% probability, something like this. And then we also see that Alice appeared 51 times in total, 50 times of that was ham. So if we get a message or an email that has the word Alice, it's probably ham. And then we have things like cookie, which only showed up 6 times in the entire corpus, and 5 of those were ham. So here we can decide whether or not cookie is even a good feature, even a good word to take into account when deciding between spam and ham. Yeah, probably it's going to be a ham word, something indicative of a good email or a good text message. But in reality, we only had 6 occurrences, so we don't really know. Whereas like Alice and cache were much more frequent. It's much more obvious. And then we've also got some other questions. If cache and Alice both appear in the message, what inference can we draw? You can kind of use that as a something to think about whether what inference we draw if both of those show up in the message. And then if credit and Alice appear in the message, does that mean that it's going to be likely that it's spam? Things to think about. So evaluation. Obviously, we're going to go back to our precision, accuracy, precision, recall that we covered earlier in the course to evaluate our machine learning model's performance. And I talked about that just a minute or two ago. So our main takeaways. I've got 15 questions for you here. You do not need to complete these as homework, as your comprehension questions, but know that machine learning is a question on the final exam. So if you do these questions and you can answer everything here, you'll be more prepared for the final exam. So I do highly encourage you to go through these and let me know if you have any questions on Canvas, email, black box, things like that. So your comprehension questions for today, aside from the Zoink activity that you did a little bit ago. So when I was in my undergrad at Iowa State, we did, I took a course on the programming language R, and we did some sentiment analysis using machine learning. So sentiment analysis is like determining whether a movie review is positive or negative. Somebody hated or loved a movie. So on Canvas, under resources, I put a file called sentiment analysis example r.zip. So I want you to download that file, unzip it, and then look through the documents in the folder. You'll find the report that I wrote for the project, the training data, the test data, the code, and the results for the original quote-unquote method of sentiment classification, and also for the stemmed method of sentiment classification. And I explain what stemming is in that document. So I want you to read through these documents, and I guess I didn't remove this part about with a partner. So go ahead and read through those documents, and then you'll answer these questions. So these are your comprehension questions for as homework for today's class. How large the training and test data sets are, and why one is bigger than the other. That's an important question. What format the data sets are in, and why I put the data sets in that format. and the format that the results are in. I want you to explain each column of those results and what they tell us. Tell how I evaluate the machine's performance. I believe I explained that directly in the report. Talk about the two methods I used for sentiment classification and why I didn't just simply use one method. So why did I use two, and then in the end, which method did I choose and why did I choose that method? And then also describe briefly how this is kind of a quote-unquote real-life example. So go ahead and answer these comprehension questions as your homework for today. Put those on Canvas in the designated spot. I think I showed you guys this meme earlier while we were still having class face-to-face, but we hadn't talked about machine learning yet. Now I think it's much more funny, so you can laugh at this meme if you want to. And then finally, if you're interested, I found this this link to some text classification that somebody did in Python with publicly available data. So if you want to give that a try, if you want to play around with Python a bit, I think it does take some time. Like when you run the script in full, it takes maybe a couple minutes to run. The computer's doing a lot of work, right? When it's doing some of these types of machine learning, the computer can take literally minutes to run a script and try to create the best machine learning model possible. So there's a lot of stats, a lot of work going on behind the scenes. So you can give that a try if you want to, and then also a machine learning algorithm cheat sheet on Canvas under resources. If you're interested in that, you can have a look there. And I think that is everything for today. So let me know if you have any questions on Canvas, email, or Blackbox, and I will see you next week.